Okay, I want you to just try to picture this for a second. The year is 1665.
Right.
London is, well, it's silent. It's basically a ghost town. The Great Plague has hit.
Campuses are empty. Anyone with money has fled to the countryside. It's a global catastrophe.
And for this one young scholar, Isaac Newton, this whole thing wasn't about fear. It wasn't about sitting around waiting.
No. For him, it became 2 years of complete, uninterrupted focus, an isolation that we now call his annus mirabilis.
His year of wonders.
It sounds like a myth, doesn't it?
And
But it's true. And that's what our deep dive is about today. We're digging into the source material on Isaac Newton.
we're not just here to list off his greatest hits. I mean, that's part of it.
Of course.
But the real goal is to understand the sheer scale of what he did. He didn't just add a few facts to the science textbook. He wrote the rule book.
He defined how we measure reality itself, how we think about motion, about force, about, well, everything.
Exactly. And our mission for you is to get a handle on how this happened. How the weakest kid, a boy who wasn't even expected to survive birth, grew into what might be the strongest, most powerful mind in human history. We're really going to focus on the circumstances that allowed for that explosion of insight.
It's the ultimate story about focus, curiosity, and, what can happen under constraints.
So let's start at the beginning. Let's unpack how that mind was built. Section 1, the making of the observer.
Well, his story really begins with loneliness.
Yeah.
His father died before he was even born.
Wow.
And then when he was 3, his mother remarried and just left. Moved away, leaving him with his grandmother.
So he grows up quiet, withdrawn.
Profoundly so. He was socially awkward. He kept to himself. And instead of, participating in the world, he just watched it.
He wasn't out playing games. He was engineering things. The sources really stress this. He had this incredible mechanical aptitude.
Oh, yeah. He was building these complex little devices in secret.
Like
tiny windmills that actually worked. Water clocks that were incredibly accurate. He wasn't just watching shadows move across the ground. He was tracking them, measuring them, trying to build something to quantify time.
His solitude was basically his first lab.
It was. And what's really interesting is that at school, he wasn't considered a genius. Not at first.
Right. He was sort of an indifferent student.
Yeah, the material just didn't grab him, I guess. The turning point was really personal. A classmate bullied him.
Okay.
And Newton, instead of trying to fight him, he decided to beat him. Academically, his competitive drive just kicked in.
And he did it.
Within months, he's at the top of the class. It just shows that once that relentless engine in his mind was actually engaged with a problem, there was no stopping it.
So that brings him to Cambridge. He's 18. He's finally in this place. It's like an intellectual playground for him.
He's soaking it all up. Mathematics, astronomy, philosophy. His mind is just opening up to the universe.
And then the world slams shut.
The Great Plague, 1665. Cambridge closes down. Everyone has to go home. So Newton has to retreat back to his family home, Woolsthorpe Manor.
He's, what, 23 at this point?
Just 23. Basically a young man forced into a pandemic lockdown with nothing but his books and his half-formed ideas.
And this is the truly stunning part of the story. This forced retreat, these 2 quiet years, they became, and this isn't an exaggeration, arguably the most productive period in the entire history of science.
He turned that total lack of external noise into the greatest intellectual synthesis of the millennium. It really was the year of wonders.
So let's dive into that. Section 2, the core discoveries. And we have to start with the apple, right?
You have to. It's iconic. And the sources say, it's not about the apple itself. Everyone had seen things fall.
But Newton asked the question that changed physics.
Yes.
Why down?
Why not sideways or up? What is this invisible string connecting the apple to the earth?
And the real stroke of genius was realizing the scale of it. He didn't just give the force a name, gravity. He made this wild hypothesis that the same force pulling the apple to the ground
is the very same force that's holding the moon in its orbit, miles and miles away.
Yeah.
And the planets.
It's not Earth physics, it's cosmic physics, it's universal.
He connected the smallest thing he could see to the largest things he could imagine.
Which leads him straight to his next problem. He needed a set of rules to describe how this force actually works.
The laws of motion, the language of mechanics. And these 3 laws, they just define everything. The first one, inertia. I mean, that one alone is revolutionary.
An object stays still or keeps moving unless a force acts on it.
Which sounds simple now, but it completely destroyed 2,000 years of Aristotelian thinking.
Right, the idea that you needed to constantly push something to keep it moving.
Newton said no. Motion is the natural state. Rest is just one version of that. That is a huge conceptual leap.
A massive one. Then he quantifies it. The second law, F equals ma, force equals mass times acceleration.
And the third, every action has an equal and opposite reaction.
And if you just stop and think about the modern relevance, these aren't just historical notes.
No, not at all. They are the absolute bedrock of engineering. If you design a bridge or a car engine or launch a rocket,
You're using Newton's laws.
you're using the exact principles he worked out during the plague lockdown. We literally built our world on those 3 rules.
It's staggering. And at the same time, he's also completely revolutionizing our understanding of light. How is he doing all of this at once?
I mean, it just speaks to his incredible ability to focus, to compartmentalize. While he's wrestling with the heavens, he's also drilling a tiny hole in his window shutter.
Right, the optics experiments.
He lets this single, pure beam of sunlight into a dark room and passes it through a glass prism.
And at the time, everyone thought the prism was somehow staining the light, right? That it created the colors.
Exactly. But Newton's insight was so much deeper. He proved that the white light wasn't pure at all.
It already contained everything, the whole rainbow.
The prism was just sorting it out, separating what was already there.
Yeah.
He showed that color is a fundamental property of light itself.
And this leads to a practical invention, too.
It does. He realized that glass lenses and telescopes were bending the different colors of light at slightly different angles, which created these blurry colored edges.
So he just invents a new kind of telescope.
He builds the first reflecting telescope, using mirrors instead of just lenses. It immediately improved astronomy, and it's the basis for modern telescope design.
Okay, let's pull back for a second. He's studying motion, gravity, planets in orbit, things that are constantly changing.
Right. And he realizes the math they had, Euclidean geometry, it was static. It was great for circles and squares.
But it couldn't describe the process of change itself.
It couldn't handle dynamics. So what do you do when the tools you need don't exist?
If you're Isaac Newton, you invent the tool.
You invent the tool. He created calculus, an entirely new branch of math designed to model change, instantaneous velocity, acceleration, the shifting pull of gravity.
He found a way to mathematically describe things that had been indescribable. It's just a monumental breakthrough.
And think about today. Calculus is the language of physics, of engineering, space travel, computer graphics, even the AI algorithms we're all talking about.
One guy, in isolation, created the mathematical language we still use to talk to the universe.
It's incredible.
So this is where it all comes together, which brings us to section 3, the complex man and the grand synthesis.
Because for Newton, these weren't separate discoveries. They were all pieces of the same puzzle.
The universe as one giant machine.
A machine operating under universal, predictable laws. And he put the whole blueprint down in 1687 in his masterpiece, the Principia Mathematica.
Often called the single most important science book ever written.
It really is. In it, he uses his new calculus to prove his laws of motion, to prove gravity. He explains everything from planetary orbits to the tides of the ocean.
But the man who wrote this blueprint for the cosmos, he was complicated.
Deeply. He was intense, pathologically focused. The sources describe a man who worked almost entirely alone, trusted very few people, and, rarely showed any emotion.
His focus was so total that people said he would just forget to eat or sleep for days.
Yeah, completely consumed by a problem. And this intensity came with this almost paranoid need for secrecy. He burned a lot of his notes.
Why?
He was terrified that someone would steal his ideas or that they would misunderstand his methods before he had perfected them.
That secrecy makes sense when you learn about his other great passion, the one he kept hidden.
Alchemy.
Yeah. Why would the father of modern rational science spend decades on what we now see as, pseudoscience?
Yeah, because for him, it wasn't. It was all part of the same quest. He thought nature had deeper secrets, hidden formulas that his math couldn't yet touch.
So he's studying ancient texts, trying to turn lead into gold.
Looking for the philosopher's stone. For Newton, physics and alchemy were two sides of the same coin. Both were ways of trying to decode the universe's operating system.
That obsessive, solitary personality, it was bound to lead to conflict.
Oh, absolutely. His biggest rivalry was with Robert Hooke, who was another brilliant mind of the time.
And Hooke accused him of stealing ideas.
He did, about gravity and about light. And the arguments were public and they were bitter. Newton was so sensitive to criticism, he couldn't stand it.
He actually withdrew from public life for years because of it.
He did. He refused to even publish his big book on optics until after Hooke was dead. That's how deep the bitterness ran.
And yet, he didn't end his life as a recluse. He did the exact opposite. He became this incredibly powerful public figure.
Which brings us to Section 4, Public Life and Legacy. It's a fascinating pivot.
He takes charge of the royal mint. He's now responsible for all of England's money.
And this was not some quiet administrative job. The currency was in chaos. People were clipping bits of silver off the coins. Counterfeiters were everywhere.
So the great scientist becomes an investigator, a detective.
A meticulous one. He oversees this massive project to recall and remake all the coins. But then he goes further. He personally hunts down the counterfeiters.
He used the same methodical observational skills he used to track planets, to interview witnesses and build cases.
He became one of the most feared and effective law enforcement officials in the country. It just proves that that kind of critical thinking, that relentless focus, it can be applied to anything, an orbital equation or a criminal ring.
And he also returned to lead the scientific community.
He becomes president of the Royal Society, guiding research across England, shaping science for centuries. His worldview became the worldview.
So when he died in 1727, the frail baby who wasn't supposed to live,
He was buried like royalty, among the kings and queens in Westminster Abbey, a national hero. His legacy isn't just in books, it's in the physical world.
So when we step back from all this,
Right.
what does it mean for you, for the listener, trying to learn and apply this stuff?
I think it means we have to recognize the power of focused attention. I mean, Newton's story is proof that sometimes the biggest leaps happen when you're forced into silence, when all the distractions are stripped away.
The plague years were a global tragedy.
A devastating time. But for Newton, they offered the one thing his mind needed most: freedom from interruption. And that freedom allowed him to build a new reality.
Which really brings us to that final provocative thought, doesn't it? That great minds often need great silence to grow. That pure curiosity, when you combine it with that kind of relentless focus, it can literally rewrite the laws of nature.
And you should never, ever forget.
Yeah, that one falling apple, seen by the right person in a moment of forced quiet, can absolutely change the world forever.